So today's topic is like because it consists of like at the unit of file, so not semantically. Sorry about that. So it contains like it's all about state ratio, but it contains how to print, reduce, select while pickles because we just enabled this of pickles, and also it partially contains how to infer return type of concat operation, and also talking about speculation and what's about speculation and how you deal with this and how it affects our state-based operation is basic content today. So let's start with the reduced operation printing. So if you look at the PR, there's some notion of eligibility. So what is this for? It's for compact output. So if your state ratio reduce is satisfied with all these 5 conditions, then when you print out this command, it can be compacted like that. It can be print in a single line like that. State ratio that reduce applies blah 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 in one line. Otherwise, if you break either rule out of these 5, then it will print not compact wise. It print almost full instruction like that. So and eligibility. So I prepare like how to print these or how to actually what kind of content in eligibility and there. So in state ratio, we also have interpret ops there. So I just want to show you that how to use this interpret ops and how it works. That how it, what output it will be. So for eligibility, number 1, the reduce operation wraps a single inner OP in the associated region. So without return operation, in the region, you should have only one operation. For example, in this example, I modify the example with a 2 addition, then the output will be something like this, not compacted. And I'll also forget about that. So, and also in interpreter ops, you have a print operation there. So interpreter like with a print operation, and if you run it with a stable ratio translate with the interpret flag, then you get the output. If you run it, you get the output.
So is it concentrated? Kind of?
Yeah, it seems so. Yeah. Yeah, I think if it accepts like function argument, it can run. So yeah, I think you can think of it as constant forwarding.
So, let's say for Mercury, I guess we have to do how do we what so in the bodies, the stability or reduced body, there should be one operation, right? So is there
Oh no, you can have a multiple operation. You can have multiple operation.
oh really?
Yeah, but then it cannot print in a
Ah,
compact way. Yeah. So number 2 is like the single operation is commutative binary operation from the like blah blah blah. So I also modify the operation with subtract, which is not commutative. Then you get this complex operation. So yeah, something like that. Also, if you read the eligibility number 4 item, the order of the operand should be equal to the order of the block argument. So I switched R0, arg1 to arg1, arg0, then you get this, not compact printing. And also the return print also need to return the operation from this single operation. So I switched it to return argument, not from the result, not from the result. I just yeah. If you switch that, also it print this complex operation. So yeah. So to print compact operation, you need to satisfy all these 5 eligibility. That's how it is written in or how it is added in the recent PR. So please look at it with this in mind. Also, there's also select operation, and depending on situation, it also print simply or complex ways. For example, in this case, true and first branch has same type, same shape and same element type. Then if you the result of this interpreter will look like this, and the result of the stable op will be something like that. So it has a very simple printing of select operation like that.
Can you go up again?
Yeah. So true and for so this is condition.
Hmm.
This is a type for true branch. This is type for first branch. And if I go down a little bit, it will become.
Okay.
Oh no no! Oh sorry. It will because true and first branch has the same type. So condition and type for true and first.
I'm kind of curious. Maybe it works for select. I'm kind of curious how it works if or like in what case the true and false branches don't
Match.
match.
Yeah, that's how I prepare.
But the true side, but it's in both sides it gives I-32, right?
Oh yeah.
I think it might work with select, but I know when I was trying to do JMP like if else statements, I don't know like because select is not an if else statement. When I tried to if else statements for JAX, it didn't allow it if the result types are different.
Yes.
Yeah.
So the only example that I try to make it not match is one dynamic shape only.
Dynamic works.
Yeah. So one is true range has 2 by dynamic.
Mhm.
First range dynamic by 2.
Mhm.
And return type is like dynamic by dynamic.
Interesting.
And in this case, because true and first branch doesn't match, so the output the to print when you're printing set operation, you need to specify all these branches together. Otherwise, it lose information somehow, right?
I see.
Yeah, there's also in a
Interesting.
and why is there's no such cases, but it just have a bunch of code to print this. So if you have this input operation, then you get this, and that in the PR you have a code to print this. So it print first like iter arg equal to %c iter arg underscore 3 equal to %c underscore 0 blah 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 can't do blah blah blah. You we have this, and maybe me and Baz and Ashley are kind of familiar with the concept of like least specific, most specific, or inference with a shape and bound. Oh, here also it adds infer concat operation for that. So there's a rule for it. So what this means is like, so if you have a static dim, left hand side, static dim X, and static dim of right hand side, the inference result of concat is X plus Y. And if one of it is dynamic, the output is dynamic. And in this case, dynamic plus X plus B, this is bound. So if your dimension is static, then you cannot have a bound. Bound can only be attached when the dimension is dynamic. So dynamic, but it has a upper bound kind of. In this case, S plus B, something like that. Both ends are dynamic and result is dynamic, dynamic, dynamic with a B bound, dynamic with C bound will be dynamic with a B plus C bound. So I also prepare this. So for C0 case, to get this, you also have a operation for the actual test infer their return types. So in this case, so static dim of 5, static dim of 3. So if you run it, the result of the type inference is 8. For C5 case, dynamic with a 4 bound, dynamic with 3 bound. If you run it, then you get the dynamic of 7 bound, because left hand side and most can have a B, and right hand side can and most can have C. So resulting can have at most B plus C. And the final content is about speculation. It's well written or described in this link. So what is speculation? So speculative execution is like, so CPU will predict branch first and execute some certain code beforehand. That's how they optimize the code execution. And the stage of the speculative execution is composed of these three. First, you need to prediction, which branches will be executed, or which data will be fluid into that branch or something like that. And then speculation, you really execute this. Commitment, if your prediction is successful, then this result will be going to register memory. But if not, you need to squash it. You need to drop this immediate result, right? And but you cannot do speculative execution for every operation. If your operation has side effect, then you shouldn't do. So the operation that can safely do this is when it is safe operation, no side effect. Though, I mean, memory read write happening during the operation or IO, something like that. So when it is safe to reorder, when it is safe to execute twice, then it is safe to do speculative execution. Also, for another case is like, so division by 0 is unsound, right? Can turn into undefined behavior. You need, for those operations, you shouldn't do condition. I mean, you shouldn't do speculative execution. Also, if your loop could be infinite loop, in this case, also you shouldn't do speculative execution. So MRIR provide a way to specify whether your operation can be speculative or not, according to some condition. That's the way to you control. And in real world, so maybe you may heard of like Meltdown or Spectre incident, and that is a security risk because of this speculative execution. So it, it when the speculative execution is fails, it should drop your result, right? But this information is resides in some certain location, and from this location you get the confidential information from that. That's the incident happened to Intel CPU. And so to model your side effect, there are two ways. One is like memory effect interface, and the other is conditional speculative interface. And there are actually 4 categories might affect speculative execution. One is like operation with a memory effect. Operation that can read or write, locate or free, that may have side effect. Also, the second is like operation with undefined behavior, something like division by 0 or loading from a free pointer. That should not do speculative execution. Third is like operation that don't terminate or infinite loop, such as except while loop with a condition that is always true. And 4 is like operation with non-local counterflow. Example is long jump. You can just move your like SB. What is it? you move your IP instruction pointer in some certain point nowhere suddenly, but there's no such mechanism to control about this item 4. So with MRI syntax, with MRI operation, MRI interface, we only control operation for 1 to 3. In that sense, maybe MSN could have far into number 1, maybe, because there we allocator free with a memlab alloc kind of. But yeah, questions so far?
I guess stack rotation is something.
Yeah, I guess.
In Emerson, actually, do we only do stack rotation?
No, there's a heap of, but for bucket accumulation, we need to allocate bucket first. So yeah, so when you use a conditional speculative, then you need to have an interface of like that returns this enum, and this enum can have 3 different values. One is speculative, that the operation itself is safe for speculative execution. Second is recursively speculative, so not only the operation itself, but also the region inside this operation is safe. And third is not speculative, so you shouldn't do speculative execution. And state ratio, there are 5 different traits to control your speculative execution. One is, but actually, yeah, I mean, intuitively, I don't understand why there's a difference between unary element wise operation and binary element wise operation, but the first trait is for unary element wise operation. So this is code, but if you simplify with a table, then depending on your shape information for input and output type, the speculative returning value is different. And I don't understand, but so for unary case, it also allows speculative for when input is dynamic and output is dynamic. But if you, yeah, I will convince you, but it's not true for binary element wise operation. Binary case, it only allows for this case only. So now currently, for only these four operation, we have this trait. So which means for these 4 operation, if the input is the shape of input is static, then it will speculative. And when input is dynamic and the output is dynamic, then it also speculative. Yes.
What is the case and like input is dynamic and output is static?
Why is not speculative?
I mean, what is the case for that dynamic and static output? I mean, second case.
Second?
Yeah. What is the operation case in the case?
Truncate, for example.
Mm,
For this operation,
Slice isn't slice like. I mean, if you're getting only like 10 elements, then,
yeah, I think that's all true. Yeah.
yeah. Okay.
I guess it's not speculable because it's not it's undefined the sizes.
Yes, yes, it is.
First and third is okay, I guess, because it's always
First thing, this one, this one, and this.
rain.
I'm not sure about this, but yeah, I'm very sure about this.
Third one is, I mean, it's always guaranteed to execute, right? I mean, there's no way this shape will mismatch.
Yeah,
In
that's also
binary
true.
case, I guess the left-hand side and left-hand side has different shape. It's gonna be undefined behavior. So
Ah,
Yeah.
oh, that makes a lot of sense. I see, I see. Right. Also, we have another condition: the left-hand side and right-hand side shape should be equal. Ah, that makes a lot of sense. The second case is like, so difference is like, so it returns not this, but recursively. So the table is same, left-hand side is same, the output is like different. It returns recursively. But for current situation, we don't have this operation that has this trait.
You know what the kind of operation is this?
Uh, uh, we can search.
Um,
Select and scatter. Maybe I can delete this trait. Because
select the scatter could be useful, no?
but uh actually I'm not sure whether it is really useful and used in our jobs, but I thought first when do you remember the first moment that I shared that, oh, this is not specific, so I remove? That's one of the operation. So
Select the scatter?
yeah.
Select the scatter. Is it kind of similar to, like, let's say,
Window reduce?
yeah?
Yeah,
not
could be.
reduction, but like, let's see, populate, your name.
Well, yeah, maybe later could be potentially I need to enable again. So that's good.
Did you leave comments on select and scatter, or is it something that's gonna be hard to bring back?
Hard to bring back, but I can do that with a small possibility of bug. But I can do that. Yeah. Anyway, yeah, that's this. And third is like, so it's for binary element wise operation. Unlike unlike unary element wise operation, it always return not speculatable if input is dynamic. Everything is same. And yeah, like the difference between 1 and 2, these 4 only difference is like it return recursively, and the operation is like map, reduce, and sort. And 5 with very long name, and it is implement to dynamic reshape of, and it adds one another on one another column, whether the shape is constant. So not only input should be static, but also it needs to satisfy that the shape should be constant.
It's static, it's just increasing, no?
I thought that, but it isn't. Maybe uh, dim op can give you. I mean, yeah, I didn't find any example, but if you read the code, that's how it is implemented.
Static and shit.
All input should be static, and all shape should be constant.
Shape related operands. So maybe if it's like, it's a strided operation, then like the output shape could be
Ellipses during the shape rate preservers.
the step size is dynamic, then the output is kind of static, and also not constant. So what's the dependency on this? Like,
Hmm. We have this. Let's see. Integration. Integration has. Is there? Oh, maybe. Shape. Static input constant shape. Is it something like this? So this is a shape that a static shape, but it's not. It doesn't seem that it's a constant shape. Let's find another example. Static input, static color unknown shape. Yeah, anyway, yeah, that's all my presentation. And yeah, I tried to find the example that whether it returns false and it returns true. I tried to find the example.
I can see that when it will return false, I mean, because it's just matching if the defining operation is constant. But yeah, so in the example of unknown shape,
Mm-hmm.
I mean, shape is still known, right? I mean, it's still two, right? So I don't know why inside here we can just still have constant shape two with.
I know what you mean. So yeah, so we know there is two-dimensional shape, but we don't know its dimension. But here we know dimension 4x5. It could be like 3x4, 3x5. You mean that, right?
3 by 5.
Because 3x5 also satisfy two.
That's only two elements, right? That's not the rank.
I see.
So below they use like unknown shape, there, but I mean, I don't know what's the difference between constant shape and unknown shape.
And I think this is I think we should look at this. So maybe
I think like what? Okay. I think the difference is unknown is from outside.
yeah.
Constant is defining sequence.
Yeah.
Okay.
Yeah. Thanks for question. Yeah, that's my presentation. And if with this presentation, I think you can review this PR very, I think, easily. So
So which opticals were added?
which opticals what?
Were added?
Not added. We add operation. We add operation in a TD files in a different PR. Maybe second or let's see here. This version issue. We added here in TD files.
So it was already added.
Yeah, TD is already added, but the ops.cpp or the file that used by ops.cpp is not added. Sorry that I added in this way, but otherwise it's very hard to add as of now.
I guess maybe in the description we can say like doesn't actually add more stable HLO ops, just adds functionality. Cause like the title gets me confused of the
Ah, I see, I see. I more detail here. Sorry.
It's okay.